So this is vectors addendum, page 3. First one says, use the properties of vector cross product to simplify the following expressions. This first one, remember that if you have A cross B plus C, that this is equal to A cross B plus A cross C. So let's use this expression here to simplify this one. So that gives us A cross A plus A cross B. And you'd say, oh, wait a second. A cross A, we have another property. When you have A cross A, that is equal to 0, okay? And so basically that's 0 plus A cross B. So basically this one simplifies to A cross B by itself, right? Okay. Now let's do C. So we have A plus B cross A minus B. And remember, we have a property. If you have A cross B plus C plus D, then you can kind of do A cross C plus A cross D plus B cross C plus B cross D. Okay, so these two are equivalent, all right? And so if that's the case, we're going to take this and we're going to expand it in a similar way, and we're going to have A cross A plus, I can kind of see where this is going, A cross B negative, right, plus B cross A minus B cross B. Okay, so it turns out to look like this. Remember that A cross A and B cross B are 0, right? And then we have B cross A plus negative A cross B, but remember, negative A cross B is the same thing as B cross A. So actually we have B cross A plus B cross A, so that's the same thing as 2 times B cross A. Okay, so that would be the second expression. I'm being a little careless here. I'm writing A's and B's without bold, without vector signs, but actually remember, when you handwrite vectors, you need to show that they are vectors by putting the arrow signs above, okay? Next one. Find all vectors perpendicular to both vector A and vector B. Hence, find two vectors of length 5 which are perpendicular to both A and B. Okay, so first of all, let's try to find any vector that's perpendicular to A and B. And remember, that's the definition of the cross product. The cross product is a vector that is perpendicular to both of these vectors. So the first step is to find A cross B. Okay, and then I'll show you how to find all vectors, which might sound hard, but actually it's very easy. So I'm going to take the determinant again. I'm sorry, I'm not putting arrows above these, but 2, 3, negative 1. 1, negative 2, 2. And the first thing I'm going to do is I'm going to find the I component. The way I find the I component is I find the determinant of the remaining numbers. So that would be 6 minus 2, which would be 4. So 4I. And then I am going to J, and now I'm going to do 4 minus a negative 1, so that would be 5J. And then actually, but I need to take the negative of that because the middle component is always minus, right? And then last of all, I am going to cover that one up, and I'll end up with negative 4 minus 3, which is negative 7K. Okay. And so this is a vector that is perpendicular to both vector A and vector B. And how do I find all vectors that are perpendicular to both A and B? All I need to do is multiply it times a scalar, and I'll just say that K is any real number. And that generates every single possible vector that is parallel to or perpendicular to both of those vectors, because any vector that is a different size that is parallel to this vector is perpendicular to the others, okay? So basically the answer to the first part is that. And then it says, hence, find two vectors of length 5 that are perpendicular to both vector A and B. Now we just need to find the two parallel vectors to 4, negative 7 that are length 5. And so To do that, first let's just figure out what is the length of the vector 4, negative 5, 7. The way we could figure that out is we just use Pythagorean's theorem. And I'm not even writing negative signs because it doesn't matter, right, when you square them. So we end up with square root of 16 plus 25 plus 49. So the answer is square root of 90. If you wanted to simplify that a little bit, you could put 3 square root of 10, I think. Okay, so that is the length of the vector 4, negative 5, negative 7. So if we would like to make 4, negative 5, negative 7 into a unit vector, a vector of length 1, we would create that by multiplying this by 1 over 3 square root of 10. Okay, and so this would be a unit vector. And then if we wanted to make this unit vector length 5, all we need to do is multiply it times 5. And now we have a vector of length 5 parallel to 4, negative 5, 7. Now what would be the second vector that would be length 5 and parallel, but in the opposite direction? It would be this one. Okay? So these are both length 5, except one's pointing in one direction and the other's pointing in the other direction. One thing that I should have said is that k here is not really all real numbers. It cannot be 0, right? So we'll say that k can't be 0. Otherwise, it can be all other real numbers. All right, let's move down to 12. Find a vector which is perpendicular to the plane passing through the points A, B, and C. Okay, so the first step here is we have a plane and it's got points A, B, and C on it. We do know how to figure out what a vector is that is perpendicular to two vectors. We don't know yet how to figure out a vector that is perpendicular to a plane. So why don't we change this problem so that instead of finding a vector that's perpendicular to a plane, find a vector that's perpendicular to two different vectors. So since we have 3 points that are on the plane, let's generate two vectors like, for example, AB, vector AB, and vector BC that are both on the plane, and then we'll figure out a vector that is perpendicular to these vectors, okay? So vector AB is going to be B minus A by the definition of the vector, okay? So that would be negative 1, negative 1, negative 7. Now vector BC would be 3, 1, negative 4, minus 0, minus 2, minus a negative 5. So that would be 3, negative 1, 1. Now all we have to do is take this vector and this vector and do a cross product, and that will give us a vector which is perpendicular to the plane. So let's do that. We're going to do the determinant again. Can you see that this is like my favorite method? You can use any method you want, but for some reason I like this one. Okay, so first I'm going to cover that up, and then I'm going to end up with negative 1 minus 7, which is negative 8i. Now I'm going to cover up the j column, and I'm going to end up with negative 1 minus negative 21, so negative 1 plus 21, which would be 20j, but I need to make it negative because the middle number is always going to be subtract. And last of all, I'm going to cover up the k column, and I end up with positive 1 minus a negative 3, which is 4, positive 4k. And so this is a vector which is perpendicular to the plane, negative 8, negative 20, and 4. You can see that I could put other possible vectors, like I could reduce this, I could put negative 2, divide everything by 4, right? So negative 2, negative 5, 1. Or I could make it into 2, 5, negative 1. These are all possible answers because they're all parallel to each other, which means they would be perpendicular to both of the vectors.